All right. So now that we have collected all of our data, usually, obviously, you would be filling in your data table, but because of the remote learning, we're just going to give you what the data will look like. So on this sheet, there's a couple things to notice. We have the soil temperature and then the water temperature that we've taken at each of our minutes. And at 10 minutes, we turned the lamp off. And so these two numbers is going to be the same as here, because where we ended with the warming, we start with the cooling. Another thing to note is that we have a change in temperature. So that little triangle T stands for change in temperature. And so here, if we take 32.1 subtracting 20.3, the change in temperature is positive 11.3. And then here, starting at 20 and ending at 23.1, it's increased by only 3 degrees. On the cooling side, because we start with a higher number than we end with, it's negative. So that negative shows that this is cooling, and the positive shows warming. Now this is a lot of numbers, and so scientists, to help organize all of these numbers, to help them see patterns, they create a graph, just like we did when we heated up water. So your graph is on the other handout that you have. And the first thing that's helpful is we have a warming and a cooling. And just in general, for this entire unit, whenever we show red, that's going to mean warm objects. And when we show blue, that is going to mean cool objects. So coloring the warming side first half red and the second half blue will help us visually.
Color it lightly.
Color it lightly, yes, thank you. The other thing we need to do on a graph is we need to add the labels. I did the time in minutes already, and then we have our responding variable, which is going to be temperature, because that is the data that we were collecting, and this is in degrees Celsius. Okay. We also need a scale, and so because our numbers are between 15 and 35, that's where we're going to start. So we're going to start at 15, and then every line is going to equal 1 degree. So this would be 15, 16, 17, 18, 19, 20, 21, etc. So this is 25, this is 30, and then 35. Sorry, my apologies, goes from 15 to 35. So that is our temperature. Then along the bottom, we have time, and we need to go from 0 to 20. So again, same idea, each of these lines is going to equal 1 minute. So this would be the bolded line is our starting point, so that's 0. Then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, and 20. And you know you've done this correct because right at the 10-minute mark is where we turned that lamp off and we went from warming to cooling. Now that we have our graph set up, we need to start the fun of graphing. So I'm going to suggest that you start just with the soil information first. So we need to get our key over here is soil. I'm using brown. You can use whatever color you want. And so what's helpful for me is I cover up the water because we're not looking at the water right now. And I'm going to, at every minute, graph a dot. So we're doing a line graph, not a bar graph. So all of this data, each dot should be on a line. So the soil temperature at 0 is 20.3, and you can estimate. I'm going to estimate as good as I can. And I kind of went between the 20 and the 21 because it's 20.3. Then at 1 minute, which is right here, right? 1, 2, 3, 4. Going to go to 22 minutes. And you can even, check off the the temperatures once you've graphed them. So at 1 minute, it's 22. Check. And then at 2 minutes, that's about 24. So I'll go up to just a little bit before 24, etc. And then ultimately, you want to follow that same pattern, okay, and checking off as you go. Once you've done the warming side, then you need to do the cooling side. So it's the same line for the cooling. And ultimately, once you finish that graph, then it's going to look like this. Okay? And then what you can do is you can then fill in the water. So the water, I'm going to change colors, and my water is going to be green. And then I can do the same thing. So on the 0 vertical line, right at time 0, you want to have a second dot, which it could overlap, like right now it's kind of overlapping, because they started off pretty much the same temperature. Then, and then check, and then at time 1, it's going to be 20.5. Check, and then at time 2, it's going to be 20.8, so almost up to 21. And then at time 3, it's going to be 21.3, and then so on and so forth. And then you would continue that, again, same with the soil where you want to do the water as well. And then you would ultimately connect all of those to have 2 lines. One line is going to show the soil, and then the other line is going to show the water. That will allow you to visually see what those numbers are. The other thing that could be helpful is this change in temperature. Okay, so one thing that you may want to just include, it's kind of, change in temperature is kind of like our average. It's kind of a summary of this data that will help us analyze it to compare the soil versus the water. That's kind of what this is. So again, that triangle T is change in temperature. And so for the soil, on the warming side, I'm going to write plus 11.3. And then my delta T on the cooling side is going to be negative 10.9. And then I can do the same thing just so that for the water, for heating and cooling, just so that I have everything on this graph that we can then use to analyze.